Hi everyone and welcome. Today I'm going to walk you through this hands-on lab, Protect Your Code Against Attacks with Gauntlt. This lab is available on QA platform, previously known as Cloud Academy. I'll read through this lab instruction, then start the lab. Gauntlt is a security testing framework that uses a command line interface CLI for running security tests or attacks. Gauntlt provides a report of tests that passed and failed, similar to other automated testing frameworks. Gauntlt integrates with many popular security tools and is easily extendable to perform custom security tests. In this lab, you will learn how to use Gauntlt for security testing and protect application code against attacks with Gauntlt by embedding it into an AWS CodePipeline continuous integration pipeline. After completing the lab, you can begin implementing security as code within your own DevOps practices. Lab objectives. Upon completion of this lab, you will be able to understand the basic concepts of security testing with Gauntlt, write and execute security tests with Gauntlt, integrate Gauntlt security tests into a continuous integration pipeline, and use AWS Cloud9 for writing code and issuing commands from a browser. Lab prerequisites: you should be familiar with basic Docker concepts, basic continuous integration concepts, and working at the command line in Linux. Lab environment. Before completing the lab instructions, the lab environment will look as follows. And after completing the lab instructions, the lab environment should look similar to this. So let's start the lab now. This first lab step, as usual, explains that we will use Sandbox AWS account available to us for 1 hour and 15 minutes. After that, the lab will terminate. Of course, we can restart the lab and the new lab instance will spin up. So for now, we can log into our cloud environment, but not start the hands-on part since our infrastructure is not all spun up at the moment. Let's read through this lab step. We have only one validation check for this lab. So this lab step is titled Opening the AWS Cloud9 IDE. Gauntlt requires a terminal and a file editor. In this lab, we will use AWS Cloud9 for working with Gauntlt. AWS Cloud9 is an integrated development environment IDE that runs in a browser. You can write, run, and debug your code in Cloud9. The Cloud9 environment can be shared with multiple collaborators to work on the same project at the same time. You can view the changes collaborators are making in real time, making it a useful tool for pair programming. Cloud9 environments are backed by either an EC2 instance or by any SSH connected machine with Python installed, including machines outside of AWS. The IDE includes an integrated terminal connected to machine that backs the Cloud9 environment. For EC2 Cloud9 environments, Cloud9 will automatically put the EC2 instance to sleep after a period of inactivity to save you the cost of running the instance when you are not using Cloud9. There is no additional cost to using Cloud9 beyond the cost of running the instance. Instructions. In the AWS console, enter Cloud9 in the search bar at the top and click the Cloud9 search result. If you are not presented with the environments view, click the sidebar accordion to show the sidebar menu and select environments. Warning: it can take a few minutes from the time you start the lab until the Cloud9 environment is fully initialized and visible in your environments. If you do not see the Your Environments view, retry accessing the Your Environments view every minute until it appears. From the Environments menu, click Open under Cloud9 IDE to view the Cloud9 IDE. After a few seconds, you are presented with the Cloud9 IDE. Take a minute to explore the Cloud9 interface. The default view shows three main panels. Environment, left panel that shows the file tree for your project. Second, editor, upper panel where you can open tabs for editing files. It displays a welcome page by default. And third, terminal, lower panel with a terminal connected to the EC2 instance backing the Cloud9 environment. The default layout is only a suggestion. You can fully configure the layout. For example, you can add, remove, resize, and split panels, open files in the lower pane, and open terminals in the upper panel. There is also a hidden pane on the right that can be opened by clicking on any of the Collaborate, Outline, AWS Resources, or Debugger tabs. The Collaborate tab shows the members of the Cloud9 environment, whether they are online or not, and their permissions, either read or read-write. You can enter messages in the chat log and also navigate to the active cursor of other members by right-clicking their name and choosing Show Location. The Outline tab shows locations you can jump to in the current file. For example, the lines where functions are defined in code. AWS Resources is useful for managing Lambda functions. The debugger is exactly what you would expect in an IDE, a tool for stepping through the code and inspecting values at runtime. In the upper menu bar, select View Syntax to see the list of languages with syntax highlighting support in Cloud9. There are over 100 languages supported. Navigate to View Themes, UI Themes, and try out a theme or two. The following lab images use the Jet Dark theme. Double-click the README file in the Environment panel to open an editor tab for the file. Cloud9 automatically creates a README MD file for new environments. Select the Environment tab in the left panel and close the Welcome and README MD tabs in the upper panel. Summary: in this lab step, you opened the Cloud9 IDE and took a brief tour of its interface. So let's go through this lab step hands-on. Cloud9, pick our environment, browse around a bit, and close Welcome and README. Okay, we don't have it currently bookmarked. Let's do that. Cloud9 bookmark. Here we have our environment available. Let's open the Cloud9 IDE. Let's keep this theme for now. And let's proceed to the next lab step. We have 1 hour and 5 minutes left in this lab instance. So this lab step is all about executing your first Gauntlet attack. Gauntlet is a security testing framework. Let's see what we have on this link. So it's a GitHub for the Gauntlet. Let's check it out. We see attack adapters available at the moment. So Gauntlet is a security testing framework that uses a command line interface, CLI, for running security tests or attacks. To use Gauntlet, you define attack files that the Gauntlet CLI executes. Gauntlet will follow attack instructions in attack files and notify you of the attack results. By using attack files, you can start to implement a practice of security as code within DevOps. Gauntlet makes it easy to integrate security testing into a continuous integration pipeline. That way, security is considered with every change of the code. Gauntlet is written in the Ruby programming language and is available via Ruby's RubyGems package manager. However, there are other ways to obtain Gauntlet. You will explore an alternative method for obtaining Gauntlet in a later lab step. Instructions. First, in the Bash Terminal tab in the lower panel of Cloud9, enter the following to install the Gauntlet gem Ruby package. And this is a command. Okay, we will read through this lab instruction in its entirety, then switch to do this step hands-on. Gem is the command used to interact with the RubyGems package manager. The Cloud9 EC2 instance runs Amazon Linux, which includes Ruby and the RubyGems package manager. The install command also installs Gauntlet dependencies. The last lines of output list all of the packages that are installed. Gherkin and Cucumber are the language and interpreter, respectively, for Gauntlet attack files. You will learn more about them later. Get the Gauntlet CLI usage information by entering Gauntlet help. The Gauntlet command searches for attack files to run. It will recursively search the current directory if no path is specified. Tags can be used to select a subset of available attacks. Currently, there are no attack files in your working directory. Create a file called first attack. Touch first attack, list all the files in the current directory, LSA. Open the file in the upper Cloud9 panel by clicking first attack and selecting open from the pop-up menu. This is one example of how tightly the terminal is integrated into Cloud9. In the first attack editor tab, paste the following attack definition. The text is an example of the Gherkin language. Gherkin is specifically designed for describing and documenting automated tests. Gherkin code is similar to how you might express running a test in English or in other spoken languages that Gherkin is localized for. You can use Gherkin syntax highlighting to help understand the file. Select Gherkin syntax highlighting from the View Syntax menu. You need to manually select the syntax highlighting because attack isn't a standard Gherkin file extension. Read the syntax highlighted attack file. A full treatment of the Gherkin language is outside of the scope of this lab. The following points explain what you need to know to understand the file. Gherkin is white space sensitive and uses indentation to define structure. Any text beginning with sharp and continuing to the end of a file is a comment. For example, line 1 is a comment and does not play a part in defining the attack. Feature is a keyword that declares the container for a group of tests or attacks in Gauntlt parlance. The text after feature describes the scope of the tests. Scenario declares a test. A feature consists of a list of scenarios. You can include text to describe the scenario. This is particularly important when you have more than one scenario in an attack file. When and then declare steps in a scenario. Given, and but are also keywords that declare a step. I launch a generic attack with and the output should contain are steps that match corresponding step definitions. Step definitions are blocks of Ruby code that implements the functionality of a step. Gauntlt includes several step definitions in addition to the step definitions included in Cucumber, the interpreter for Gherkin. The generic attack step definition executes the code between the docstring quotation marks. The output step definition uses a regular expression to match the contents included in the docstring quotation marks. There are also variations such as the output should contain exactly, which uses different regular expressions. The scenario is verifying that the current directory is included in the output of LSA. This is always true. Attack files can include multiple scenarios. Although Gauntlt focuses on security tests, it is a generic framework that allows attacks that are not assessing security. Press Ctrl S on Windows or Command S on Mac to save the first attack file. Press Alt S on Windows or Option S on Mac to switch your cursor back to the terminal. List the step definitions included in Gauntlt by default. Gauntlt-S. Among the output you can see the step definition that implements the generic attack step used in the first attack file. The output should contain step is not listed because it is not a Gauntlt specific step. Entering Gauntlt-A lists all step definitions, including those that are part of Cucumber. Execute the attack by entering Gauntlt. Gauntlt recursively searches the current directory for any files that end with .attack. The output should resemble the following. The end of the output notifies you that the scenario passed and both steps in the attack file also passed. Press Alt Option S to switch back to the editor and change the second step to search for 3 dots instead of 1. There is no such file, so the attack scenario should fail. Press Ctrl Command S to save the file, then Alt or Option S to switch back to the terminal. Press the up arrow followed by Enter to rerun the attack. The red color is used to indicate failures. The summary at the end, as well as the annotated step text, is colored. The annotated step shows a diff of the expected output and the actual output that caused the step to fail. The failing scenarios section lists the scenarios that failed and gives the corresponding file line number and scenario name. Summary. In this lab step, you executed your first attack in Gauntlt. You installed Gauntlt using the RubyGems package manager. You also learned about the structure of Gauntlet attack files written in Gherkin. An attack file contains a feature that consists of a list of scenarios. Scenarios correspond to a security test or an attack. Each attack is made of several steps. Each step must have a corresponding step definition that tells the interpreter how to perform that step. Okay, let's replicate this now hands-on in Cloud9. Let's copy paste this command gem install Gauntlet and the specific version. Let's open this file. And let's highlight the syntax. We are looking for Gherkin. CD. Okay, this. Okay. Let's see if I change the theme. Let's use this theme. Okay. I like it better. Now let's list the step definitions, closed by default. So in first attack we have when I launch a generic attack with and let's execute the attack. Screenshot here shows one scenario passed and 2 steps passed. Okay, then we will change the file with 3 dots instead of 1. Okay. Yes, as expected, one scenario passed with 2 steps. Then we will change the file at 2 dots, save, and rerun the attack. Okay, now it failed with 2 steps, from which one failed, one passed. Yes, exactly as shown in the lab instruction. That should be it for this lab step. Let's proceed to the next step, working with Gauntlt attack adapters. Let's read through the step, then switch to the hands-on part. In the previous lab step, you executed an attack that included a step written as when I launch a generic attack with. The word generic in the step refers to an attack adapter. In Gauntlt, attack adapters implement the step definitions. Gauntlt includes several attack adapters. The generic attack adapter step definition allows you to run any terminal command. Other attack adapters are built around existing security testing tools. Using an attack adapter for a specific security tool is more convenient than trying to use the generic attack adapter and generic output parsing steps. Although the attack adapters are installed with Gauntlt, the status of the security tools are independent of it. You must ensure the tool is installed before Gauntlt can run attacks using the tool's corresponding adapter. Instructions use the list command to show the available Gauntlt attack adapters. Gauntlt list, we'll see defined attacks. To gain some insight into attack adapters, the following bullets summarize the use cases for each. Arachne, Web Application Security Scanner. Curl, a tool for transferring data, but useful for testing if something exists. DIRB, a web content scanner that can be used to discover hidden pages, such as administrator login pages. Garmer inspects website responses for basic security requirements based on Mozilla's Web Application Security Coding Guidelines. Heartbleed tests for the Heartbleed vulnerability. Nmap network mapper for performing port scans for penetration testing. SQLmap detects SQL injection flaws for a variety of database management systems. SSLize analyzes SSL configuration and can identify weak cipher suits or other vulnerabilities. Note that AWS provides an acceptable use policy that restricts the kinds of security tests that you can perform. In general, you are allowed to perform vulnerability and penetration tests of your own systems, but you must request authorization first. Create a directory for the attack you will create and change into it. XSS is an abbreviation for a cross-site scripting attack. XSS attacks allow attackers to inject malicious code into an otherwise trusted website. You will use Arachne to test for XSS vulnerabilities. Create an attack file by right-clicking the XSS folder in the environment panel and selecting New File. Enter XSS attack for the file name. Double-click the XSS attack file to open it. This time Cloud9 knows to use Gherkin syntax highlighting for the attack file. Pass the following code into the file. This attack file introduces a few new Gherkin concepts. Add indicates a tag. Tags can be used to label and run subsets of attacks. The @slow and @really-slow tags configure Gauntlet to use a 30-second or 10-minute timeouts respectively, instead of the default 3 seconds for a scenario. Given declares preconditions that must be satisfied before performing an attack. The profile in the code is a Gherkin table where columns are separated by straight line. Table values can be used in the following steps by specifying a row name between angle brackets such as URL. Tables make it easy to adapt an attack file to different environments. The Arachne command checks for XSS vulnerabilities and limits the scope to a single page. The URL is retrieved from the profile table and is https www.oasp.org. Open Web Application Security Project website. Switch to the terminal with Alt or Option S and run the attack. Gauntlet. The scenario fails with output similar to the following. The red annotated Arachne step provides the reason for the failure. No such file or directory Arachne. Recall that attack adapters depend on the underlying security tool, which is not installed by Gauntlet. Replace the XSS attack file contents with the following. There is only a small change in this version of the attack file. The given line now includes a precondition that ensures Arachne is installed. The profile table is also included as before by joining the preconditions together with the AND keyword. Run the attack again and compare the output with the previous run to see which error message is clearer. Install Arachne by issuing the following commands. wget Arachne, extract it, and add it to path. The final line includes Arachne in your environment's path variable, so Arachne can be executed from any directory. Run the attack again. Gauntlet and read through the output as it appears. Now we expect to see one scenario passed with all 4 steps passed. The attack takes around 6 seconds to complete and all steps pass now that Arachne is installed. In summary, in this lab step you learned about attack adapters in Gauntlet. You wrote an attack file that uses the Arachne attack adapter. You saw what happens when you run an attack and an underlying attack adapter is not installed. You can include a precondition in your attack file to check that an attack adapter tool is installed to make debugging issues easier. You also learned about tags and tables in Gherkin. So let's do this part hands-on. We have 35 minutes left in this lab instance and 2 steps more after this one. So when we run the attack, we expect one step to fail because the Raj is not installed. See? Yes, exactly. Let's do that. Now we see all 4 steps from this scenario passed. And let's proceed to the next lab step using Gauntlt to test a local application. In a DevOps environment, you are most likely to be security testing your own applications. In this lab step, you will run an application that has intentionally been left vulnerable to several attacks. The application is called Rails Code. A couple of screenshots of the Rails Code web application are shown below. Rails Code is developed by the Open Web Application Security Project, OWASP, and is made to educate developers and security professionals. The vulnerabilities in Rails Code follow the top 10 application vulnerabilities identified by OWASP. If you are interested, you are encouraged to read more about the vulnerabilities and the security tools that Gauntlt supports to detect them after completing the lab. This lab focuses on using Gauntlt and will not go into the details of vulnerabilities or Gauntlt's underlying security tools. You will run Rails code in a Docker container and also use the official Gauntlt Docker image to run Gauntlt inside of a container. The Gauntlt image comes with security tools installed. It is a convenient way to use Gauntlt and not have to worry about installing security tools separately. Instructions: delete the Cloud9 AWS Lambda Docker images and remove Arachne installed in the previous step, which pre-installed in the Gauntlt container to free up some disk space. Remove Docker images and Arachne binary. Oh, let's instead of me switching from the lab instruction to the Cloud9, let's read through the instruction and then switch to hands-on part. So this section does not have any validations, and after this one we have one more left to go and 27 minutes in total from this point on. Cloud9 integrates tightly with AWS Lambda and includes Lambda images for several languages. However, the Lambda Docker images bring the 8 GB file system close to capacity and do not have enough space for the Gauntlt Docker image. You can safely delete the images for the sake of this lab. In the Cloud9 terminal tab, use Docker to run the Rails code application. Docker network create attack, Docker run, name Rails code network attack, the OWASP Rails code Rails with command Rails DB setup Rails server. It takes a minute for the Docker images to be pulled down and for the application server to start running. The server runs on TCP port 3000 in the container. The container runs in the user-defined network named attack. The Rails code port is accessible to any container in the attack network. Docker also provides name resolution for mapping the container name Rails code to an IP address inside the attack network. Check the container logs to verify the application server has started. Docker logs Rails code. The server is up and running when you see this stated Fabric HTTP server start paid port 3000 on the last line of the logs. Reissue the command if you do not see the line in the log output. Cloud9 will pop up a help message that is aimed at debugging Ruby applications. You can close the message since it does not apply to you. Create a directory for Rails code attacks and change into it. Create a file named app attack in the Rails code folder and open it in an editor tab. Paste in the following attack file contents. The attack file includes two attacks, one using the Arachne attack adapter and another using the curl adapter. The attack file demonstrates a few more features for gherking. Background steps are executed before each scenario and are a good place for common preconditions. The table declares the attack target URL as HTTP Rails code 3000. This URL is only valid from inside the Docker attack network. Tags can decorate scenarios as well as features. The @slow tag extends the timeout of the Arachne attack scenario only. A scenario can be executed multiple times using rows from an examples table. This is illustrated in the second scenario. The scenario uses the scenario outline keywords to indicate that it gets values from rows in the following examples table. Even with the slow tag, the Arachne attack does not have enough time to completely scan the application. For the sake of time, the 30-second slow timeout is used to limit how long Arachne runs. It will not find any XSS vulnerabilities within that time period. The curl attack scenarios check that the track and patch HTTP verbs are not supported, while the get verb is. The curl attack is intentionally made to fail for demonstration purposes. To determine what regular expressions to match in the output, you can run the commands from the command line. You do not have to run the commands individually after you codify the attacks. Gauntlt automates everything from that point. From the Terminal tab, run the Rails Code attacks using the Gauntlt container with security tools pre-installed. It takes a minute for the Docker image layers to be pulled. The command options serve the following purposes. rm deletes the container once it exits, which is as soon as Gauntlet finishes running. V mounts the current directory into the container's working directory, so the attack file can be discovered by Gauntlet. Network attaches the Gauntlet container to the attack network, so Gauntlet can access the Rails Code application on the network, and TTY allocate a pseudo TTY to enable output text coloring. Once the text finish, output similar to the following is shown. So we expect to see one failed step and one failed scenario from this screenshot. Although the Arachne attack times out, it does not count as a failure because it detects no issues within the time it has to run. The only attack that fails is the curl attack, verifying that the patch method is not supported. The Rails Code server does not support the patch verb, so it fails. Notice that you can search the output for the word failed to determine if any attacks failed. Gauntlet also returns a non-zero exit code if any attacks fail. This makes it easy to automate in a pipeline. Summary: for this lab step, you use the Gauntlet Docker container to scan an application running on the local environment. Using a container for Gauntlet is convenient because it is a portable solution and comes with security tools pre-installed. You also saw how to include multiple attacks in one attack file, how to share preconditions using a background section, and how to reuse an attack scenario by including an examples table. So let's quickly do this part hands-on. We have 19 minutes left in this lab instance. We have 2 steps failed and 2 scenarios failed. So let's proceed to the next step with validations. We have 14 minutes left. And this last step is titled Including Gauntlt Security Testing in a Continuous Integration Pipeline. You have seen how to run Gauntlt as a standalone tool for checking the security of your applications. To gain the most benefits from security tests, you should run them frequently and in an automated fashion. Running Gauntlt inside of a continuous integration or delivery pipeline is a great way to achieve both. This lab step will demonstrate how to integrate Gauntlt into a continuous integration pipeline. AWS CodePipeline is the specific pipeline chosen for the lab. Following the same basic approach, you could integrate Gauntlt in other continuous integration pipelines. The Cloud Academy lab environment has created a code pipeline for you. It watches for source code changes in a versioned Amazon S3 bucket and runs an AWS code build operation when new code is uploaded to S3. The build operation uses a build spec YAML file that code build can understand to perform build operations. The pipeline does not include any security tests. You will add the security test stage into the pipeline in this lab step. You will do so by making another code build specification that is devoted to performing security tests. For simplicity, there are not any actual code files other than the build specifications and a tag file. The build and test operations will make use of Docker images instead, namely the Rails, Goat, and Gauntlet images. Instructions: click here to open the code pipeline dashboard in a new browser tab. Click on the pipeline in the table to open its graphical representation. Observe the pipeline that has been created. Source and build stages. The continuous integration pipeline consists of a source stage and a build stage. The source stage kicks off the pipeline anytime source code is uploaded to the S3 bucket that the stage is configured to watch. The build stage builds the application and produces build artifacts that are uploaded to S3 whenever a build succeeds. There is no testing embedded inside the build stage. Click Edit so you can modify the pipeline to include a security test stage. Click on plus add stage between the source and build stages. Enter a name of security test for the stage and click plus add action group to define the stage action. Enter the following values in the add action form: action name security test, action provider from test to AWS code build, input artifacts source output, and project name app test. Cloud Academy lab environment has created a code build project name app test for your security test. The project is configured to run tests in a build spec test YAML file. The test stage is configured to take the S3 stage's output, which is the source code, as its input. The test stage does not produce any output artifacts. Click Done to save the security test stage. Click on Save to confirm you want to save the configuration changes. A dialog box is shown. Click Save again. The pipeline will currently fail at the test stage because there is no build spec test YAML file in the source code. Return to the Cloud9 terminal tab and create a new file named build spec YAML in the Rails Go directory. Paste in the following AWS code build spec YAML build specification. This is the file that is currently used during the build stage of the code pipeline. The build spec format divides the build into multiple phases. For simplicity, the pre-build and build phases are not doing any useful work, but should always succeed. code build will fail the build if any of the commands return a non-zero exit code. The post build creates a zip file of the build artifacts, which are simply any YAML files in the build directory in this case. The artifacts section configures the files to be uploaded to S3 as a result of the build. In this case, the zip file is uploaded. The artifacts are passing by CodePipeline to any following pipeline stages. Create a build spec test YAML file in the Rails goats directory and paste in the following contents. This is the build spec that the test pipeline stage is configured to use. Notice that the Docker commands are the same as you entered at the command line in the previous lab step. Code build will execute the same commands, and if any tests fail, the Gauntlt container will return a non-zero exit code. The entire test stage would fail as a result, and the build stage would never start. It is not worth noting that code build supports caching specific files and directories to S3. In production, you can improve pipeline stages by strategically caching dependencies. In the Cloud9 Terminal tab, create a zip file that you will upload to S3 to trigger a new build. Upload the zip file to the CodePipeline S3 source bucket containing the code artifacts. Return to the CodePipeline browser tab and watch as the stages are performed. You should notice the source stage move to in progress within a minute of uploading the source zip file to the bucket. You can click the release stage button if you do not want to wait. After approximately 3 minutes, the security test will fail. Remember that the test stage is pulling 2 Docker images that take most of the time. Caching could help improve the performance. Click on View Logs in the Security Tests action to open a summary of the failure. Observe the expected failure during the build stage in the Phase Details tab due to the failing curl attack. The Build Logs tab provides the output from the security test to probe deeper into the cause of the failure. And in summary, in this lab step, you configured an AWS CodePipeline continuous integration pipeline to include Gauntlt security tests to protect your code against attacks. You use the same Docker Gauntlet commands inside an AWS code build spec file to automate the security tests. So let's test this validation check. At the moment we expect it to fail, and then we'll proceed to this lab section, hands-on. Okay, let's proceed to the hands-on part. We'll add a stage and name it security test. Add action group with the action name security test. action provider test AWS code build. Two minutes left. Let's see if I can wrap it up until then. So it says that after approximately 3 minutes, if you don't have, the security test will fail. Let's see. Let's try it out. It's running at the moment, in progress. And we expect it to fail. 45 seconds left. And let's view the details available right now. Ten seconds. Let's check again here. Depending what validations checks if the security test state has been added to the pipeline. Great, that validation check passed, and with that we completed the lab. So that would be all for this video. Like and subscribe if you enjoyed this one. Until next video. Bye for now.